All right, guys, I'm recording this so that you can see how to find this stuff using a calculator. As you worked through number 4, it said, what are the local maxima? Okay, a local maxima is a maximum in a problem. Here's a problem. By the way, look at my y equals. Here's a quartic equation that opens which way? Up. So y equals x to the 4th minus 9. It opens up. When I look at the graph, that graph comes up. So I'm going to try to find the coordinates of that point. Look, right here. I'm trying to find the coordinates of that point right there. To do that, guys, don't need to watch in the back. Like this. Second, calculate. We are looking for the maximum. We're looking for the maximum. So punch the number 4, and it will find the maximum. Look, it says left bound. That means you need to take that little spider right there, that's blinking spider, and getting to the left of that point. See it? See that thing? You got to get it to the left of that maximum point. So anywhere to the left. Just get it over there to the left. You hit enter, and look what it says now. It says right bound. So now you have to move it to the right. For lack of a better term, I'm calling that little blinking thing right there a spider. So I take that spider and I hit enter. And I have to hit enter twice because it gives a guess. And then it will tell me what word it says. What word does that say right there? Maximum. Now it's a local maximum because what happens up here? Do these points stop right here? No, they keep going. Over here, they keep going. So it's a local maximum. It's not the maximum of the graph, but it's a local one. Because this picture really doesn't have a maximum. But look at this. 1.45236 e to the negative 6. Or in other words, 0.000001452. In other words, 0. So the maximum is 0.10. That local max, guys. I'm reading number 4. The questions say, look right here. The questions here say, when I punch graph, it looks like that would be 2 negative. That looks like that could be right. But those aren't maximum points. What are they? Minimum. Yeah, those are minimum points. The maximum is up above. Guys, in a little while, I'm going to change the equation. We'll get down here and we'll change the equation, and we'll do the same thing, guys. We're going to find maxes. We're going to find maxes up here. We're going to find minimums down here. Every time it crosses the graph, we're going to find a 0. Guys, I'm going to go through all those questions. And that's why if you need to get to this again, I'll record it tonight and put it on record. But you better learn how, or you better pay attention to what's going on with your calculator. That's because it can be a useful tool if you know what it is that you're looking for. But if you don't know what it is you're looking for, guys, you might as well not have it. Also, several of you are running into this. There's a game y'all play or something. When something happens, a set of things that you punch, and these stat plots get turned on. And when they get turned on, when you try to graph stuff, it won't let you graph unless you're in the stat mode. I'll teach you later in the year how to do that. So if you ever try to graph and it says dimensions arrow, what you do is you go second stat plot, and one of these words right here must be turned on. There's a bunch of them. Just move up or down, get to the one that's on, and then scoot your arrow over and turn it off. Okay. Another thing that's been happening to people is their graph isn't right in the middle. To get it right in the middle, zoom standard. That gets 10, 10, 10, and 10. So now it's right there in the middle. But that's not the only graph in it, but it's a useful way to look at it. All right? one other thing in terms of your calculator, one other thing here, if you wanted to look at the table of answers, look, table. There's a table. Table start. Delta. There's a Greek letter delta again. Delta table. Zoom. 6 is standard. Second, format. Lets you format what the things look like, whether it's got a grid or anything like that. Somebody had this. Somebody had their calculator. The mode somehow or another had changed. Somebody had changed it to a different mode, so it didn't have y equals. So when I punched the y equals button, it had this, and so I knew right off what was wrong with it. Guys, if that doesn't, when you punch y equals, if you don't get y's right there, you're in a different mode. You're not in. What do you think FUNC means? Function. You aren't in the function mode. So you change it to function mode, and I'm ready to graph this. So I type it into the calculator, and let's look at number 11. Let's look at number 11 together. Number 11 says domain. What's the domain always? But that's what you're going to say, all real numbers, but you're going to write. And guys, if you don't, I'm going to mother wrong. I'm going to count off for it. I'm telling you right now. Negative infinity, comma, positive infinity. The range, negative infinity, positive infinity. The degree, I just typed it, guys. That was the highest little bitty number I typed. Cube. So it's a cubic of a third degree. It's entirely up to you. Leading coefficient, 1. Symmetries, neither. Guys, neither symmetry. Okay, so now look, the directions say zeros. Watch this. Look at the picture. Guys, how many times does this graph right here cross the x-axis? 1, 2, 3. It crosses 3 times. So that means when I try to calculate the zeros, how many answers do I got to get? 3. So what I'm about to do, guys, you got to do 3 times. And every time you calculate a zero, it's going to ask you for the same thing. It's going to say left boundary first. So you got to get to the left of that zero. Hit enter, then get to the right of that boundary, and it'll tell you what it is. It's negative 3.06. So the first zero is negative 3.06. Again, this thing is going to have 3 zeros, 3 roots, 3 solutions, 3 x-intercepts. You with me? Same word. This week, it's enough for us to just decimal those off. Next week, when we get really good at this stuff, we'll find some exact answers. But right now, we're just looking at the picture, and we're going to go second. Calculate. Again, I want to know that second zero, so I got to be to the left of that dotted line, or that line right there. Am I to the left of this point? Yeah, it doesn't matter how far, so I'm to the left of it. I'm push enter. Now I got to get to the right of it. So I got to take my little spider, run him across the line, and get him to the right of that point. Now I'm to the right of that point. Hit it again, and it'll tell you where the other zero's at. 0.17. So 0.17. I'm rounding off. Second, calculate. I need the 0. I'm to the left of it. Got to get to the right of it. Man, second, calculate. Now I got to start all that stuff up. I don't got to start all of it. Forgive me. Got to get to the left of it. Got to get to the right of it. 1.89. And that's my zeros. Is this point where my finger's at right now? Is this point a max or a min? It's a minimum. So second, calculate, minimum. 3. I got to get to the left of the lowest point. Because look, it says left bound. So I got to get to the left boundary, move over here, get to the right of it. Minimum. Look, it says the word minimum right there. Minimum. 1.12. Comma, negative 3.06. Find the max. It does it for you. Second calc. Max. Got to get to the left of it. Got to get to the right of it. Negative 1.7. Nine and 9.21. Oh, these are approximations, so I guess I should put equal sign with a dot over it. Or if these are approximations, then squiggle them. Approximately. Max. Approximately. Yeah. The range is all real numbers because this line that goes down into the left, that gets every y. That gets every y. Here's y right here. 0. Where my finger is right now. Y is 0. Now what's y? Negative 1. Now what's y? Negative 3 now. Look, this line going down, that gets every possible y there is. This gets every possible positive y there is. So it's all real numbers. Okay? So now I got to do my interval of increase, interval of decrease. So now I got to go from negative infinity to, make sure you use your x value. So from negative increasing is from negative infinity to negative 1.79. Then what's it do? It decreases from 1.79 to 1.12. Then what does it do from 1.12 to the rest of the time? It increases again. That's what you want. In this one. All that's going to happen, and I'm going to leave number 12 for you tonight. All that's going to happen in number 12 is you'll have another term. So you'll have another set of zeros. So you have another increase or a decrease or whatever. But the process is the same thing. It's x to the fourth. So there could be 4 zeros. You may have 4 times. 4 different times over there. You may have to find them. Number 13. Guys, if you miss number 13, it's just because, again, as a lot of the questions we do when I let you use these calculators, if you just know what your calculator can do, guys, there's no need to miss it. It's x to the fourth. So put in x to the fourth. Look, hit graph. Draw that picture. Draw that picture right there. Put it on your graph. Well, that's the parent graph. And then what's the second thing it says to do to it? So to take that same picture, take that same x to the fourth, and subtract 4. What's that going to do to the picture? Drop it down 4. Drop it like it's hot. Down 4 units. What would a plus 4 do? Look at the next one. What does that number in the parentheses do? Is it left or right? What does a 2 do? Vertically stretches it. What does a fraction do? Shrinks it. What does a negative do? Flips it. Guys, that's going to be true. That set of little transformations right there is going to be true the rest of this year. That goes on forever. That's what's cool about functions. They have so much thing that are in common with one another. They have some things that are just alike. So guys, when you walk in the door tomorrow, I'm going to do 12. We'll answer 14. If you need me to run through one of these again, I'll run through them. But don't forget, guys, if you want to practice some of this stuff,